So are we ready for coin and age problems? That's our objective for tonight. Coin problems we worked a little bit with last year, and the main thing to remember about coin problems is you have to consider the amount and the value. Most of ours will be value, but you may occasionally have one where it's just the amount of coins that you have to deal with. Typically, you're given information regarding both. Amount is the number of coins. So say I have 10 nickels. Well, that's not 10 cents. 10 nickels is not $10. So you have to consider what the value would be of the number of coins that you have. Okay? So we'll start with coin problems. And we want to look at the number and the value. Typically, you will have mostly value problems. The first one, you have Joyce, I believe, has 9 more quarters than dimes and twice as many nickels as dimes. If she has 73 coins, how many of each does she have? So what do we know the least about? We know the least about dimes. So I would let D equal dimes. And then I know she has 9 more quarters than dimes. So D plus 9 equals, this is the number. Sorry, I should have been specific there. This is the number of quarters. And then 2D would be the number of nickels. All in all, she has 73 coins, so I would sum those up 73, and then I would solve that. And you can go ahead and do that. Okay, so if you want to pause it here and come back and let me know what you got, that'd be great. You should have gotten 16 dimes, 25 quarters, and 32 nickels. Okay? Now, the value one, you have to set up your let statements, and then you have to convert it over into coins and cents. Okay, I always do mine in cents versus using decimals. So then we solve and we check it. So in order to do that, we think first, what is the value of X nickels? What is the value of X nickels? It's going to be 5X. Okay, if I have 5 nickels, it's 25 cents. If I have 10 nickels, it's 50 cents. What is the value then of 2X minus 6 quarters? Well, it's going to be 25 cents times the total number of quarters. 12 dimes would be, you should know that in your head, but it's 12 times 10, which is the value, which is 120 cents. Okay? X nickels and Y dimes, think about an expression for that, and I would have 5X plus 10Y. Good? All right, so I don't use typically these cents in mine. I put everything in the hundreds just to make it easier. All right, so let's go on with our coin problems here. Charlie has twice as many nickels, twice as many quarters as nickels. If he has $9.35 in coins, how many of each does he have? All right, so I would let maybe N equal my number of nickels. And if I have N nickels, then I have 2N equals the number of quarters. Now we need to think about what are their values, okay? So the value of N nickels is 5N. And the value of 2N quarters is 25 times 2N, which is 50N. Make sense? And the total value is $9.35. Again, back to this up here. I am going to, basically I multiply through by 100, but I do everything in cents, okay? So I'm going to say that 5N plus 50N equals 935. And I would solve that, and you should solve that. All right? So I would get 17 nickels and 34 quarters. And I always check with the value of that. Okay, so 34 quarters, how much is that? 17 nickels, how much is that? Well, 17 times 5 is 85, and 25 times 34, well, 34 quarters, I would divide it by 4 and figure out what that would be, and it's 850, and if I add that together, it's 935. Check. Okay? So I'm going to let you guys go ahead and do 2 and 3 there. I don't think it's overly crazy. Remember when there are 30 coins in all, okay, if I let x equal one of them, if x is my number, say, of nickels, how can I represent my number of quarters? Well, if I have, let's say I had 30 coins in all and I had 10 nickels, how many quarters would I have? 20 quarters. How'd you get that? I subtracted it from 30. Okay? So you guys should be able to do the next couple of problems on your own. And we're going to go ahead and talk about age problems. All right, think about this for a minute before we get to the notes. How would you represent 7 years from now? Not rocket science, right? I would add my age now to 7 years. If I was 12 years old 4 years ago, that's 12 minus 4. If I'm 12 years old now, 4 years ago, I would be 8. If I'm X years old now, 6 years from now, I would be X plus 6. This is all, it kind of seems second nature, and you're wondering why I'm even bothering, but when you see the age problems, you will see why. All right, because we have to think about then and now and then and forward and backwards and upside down and inside out. All right, Toto is twice as old as Dorothy. In 6 years, the sum of their ages will be 60. How old is each now? So you have to set up a now and a then, or a now and a fast forward. All right, so now, right now, Dorothy's age is X, sorry. Toto is twice as old. In 6 years, Dorothy is going to be X plus 6, and Toto is going to be 2X plus 6. All right? And in 6 years, the sum of their ages is 60. And I'll let you guys solve that, okay? I don't need to do the algebra for you. Pause here, and then come back. You should get Dorothy is 16, and Toto's 32. That's final answer. Let's take a look at another one. How about Twinkie and Ding Dong? Twinkie is 8 years older than her brother Ding Dong. In 3 years, Twinkie will be twice as old as her brother will be then. And how old is her brother? So you're going to set up let statements for now and in 3 years. You should go ahead and try that on your own and then come back and check with me. All right, so I get that X is going to be how old Ding Dong is. And that means X plus 8 is Twinkie. In 3 years, Ding Dong will be X plus 3, and Twinkie will be X plus 11. So I set that up. Okay, so in 3 years, Twinkie will be twice as old as her brother will be then. So this is how old they are in 3 years. All right, so now Twinkie is twice as old as her brother. So we're going to set up Twinkie is twice as old as her brother. All right, and then you solve that, and you should know that you get, dun, 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 X equals 5, and they want to know how old is her brother. So the brother is 5, right? Because Twinkie is twice as old as her brother, so I want to know this. Oops, 5. Good. All right, let's do a one that was in the past, maybe. Or let's do number 6, because 6 is kind of tricky. All right, Calvin is 7 and his mother's 37. So your question is, why are you even asking me this? Well, they want to know, in how many years will his mother be 3 times as old? Okay, so now Calvin is 7 and mom is 37. In how many years? Okay, X years. Oops, X years. Calvin will be 7 plus X, and mom will be 37 plus X. And I want to know, in how many years will his mother be 3 times as old as he is? So I want to know, mom will be 3 times as old as Kelvin. Okay, and then you can solve that. I think you should be pretty good with the rest of this, so I'd like you to try them on your own. Why don't you pause it here? I will post the answers, and that way you will know whether or not you are doing it correctly. Okay? So go ahead and pause, and I'll put the answers up. All right, so in number 2, you should get Polo is 38, and Marco is 15. In number 5, Mocha they're asking for. Mocha's 16. All right. And Apollo and Zeus, they want to know about Apollo. Apollo is 7. Okay, 7 years old. Sound good? And we'll do more coin and age tomorrow. Have a great night.